let me give it a return type integer. I want my function to add something. Give it two variables, int a and int b. Now, within my function, that's the powerhouse of my function, I want to take another variable c, and I want to store the result of a plus b in c. Then I want this function to return c. I want to believe that nobody is confused with what I have on my screen, right?
Yeah.
Nobody, right? Are we together, please? If you're confused, we are here to learn. Oh. Like, there's nothing wrong in saying I'm confused. Okay, so what I'm doing on line 12 is I'm calling my function and I'll pass in two numbers, two random numbers. Now, the bone or the point of contention is okay, since we know what this program is will do, let me just copy this and bring it to my whiteboard so we'll be evaluating it together. So I'll just paste it here. Yep, somebody's hand is up. Yes, if you have pseudo pretending to be who was that?
Lone Wolf.
Okay,
Oh,
Lone
sorry,
Wolf, go
sorry,
ahead.
sorry. It was a mistake. Sorry, I've removed it. Sorry. Sorry for wasting
All right,
five
no issue,
seconds or 10 seconds of time.
no problem. So for this tutorial, I've seen more complex. When the control gets here on line 5, what the control will do is just to add a plus b, then return the result back into c, right? It will just add a plus b, then return the result back into c. Here is constant. Do we agree? The time taken is it will always be constant, right? No matter how many times they are calling this
Yes.
particular distance, line 5 will always be constant. Now, how about line 6? How about line 6?
Line
Also, it
60
will
is
be
also
constant.
constant.
Line 6 too is constant. Now, looking at the other right? So big O of one for this one and for this one. Now coming back to my um human made logic, or how do I put it now? So we have the O plus one constant time twice. How do we calculate it? So O of one plus O of one will give us big O notation of two, right? They are constant. So even though I have O of two here or O of 2,000,000, so we can say when you have we have a program that is not dependent on maybe the number of inputs or size. Like you have to go through, if you want to calculate the order of the time taken, you have to go through each line of your program. And if all of them are constant, you can assume that, or you can just give it that, okay, it is O of one, which will take constant time. I think it's as simple as that. Is there any question? Is there any question on this
Never,
one?
never clear, never clear.
Okay. So we want to be able to calculate the time complexity. Why are we calculating it? Back to this my question. Why big O notation? Now, you want to write a program. Definitely, we are not just writing programs for fun, right? We are doing these things because we want to be able to develop something, maybe an app, a web application, or a phone, or whatever I want to develop. Now, you don't want a product where you don't want a product where your app, in this case, for example, will be lagging, or if maybe someone wants to want to make use of your website now, and it takes like more than 3 minutes to load. Trust me, nobody has that time. I leave those kind of sites faster than anything. Abby, you don't want to spend much time on maybe a particular thing that another app that is working the same way will take just one click or 1 second, and you're done what you want to do, right?
Yeah,
Exactly.
yeah,
Yeah.
Yeah. So you want to develop an algorithm that will be very, very much fast. That'll be very, very much fast. And we don't want I actually wrote a program here. Let me show us. A program that calculates the time it takes for each algorithm is not constant. Yeah, but at least it's calculating it. Abby. So let me veer into the program. Sorry. CD personal. Uh-uh. Okay. Practice. So see the program here. Now with this clock function, you add it at the start of your program, then you add it at the end of your program. Now, it will give you the time taken for your program to run. It's not constant, but you need to maybe you approximate the time you're getting or something to get the time. But like we made mention earlier, you can't rely on this because machines differ. What I'm doing on my system or the apps that are loading on my system is very much different from what you're doing on your system. So a very good way to be able to analyze your program is the big O notation. So the big O notation will tell you how fast or how slow your program is taking to run. Right. So let me go back to the topic at hand. One, two, three. Okay. So code setting VI big O. So now if you want to analyze your program algorithm, yeah, we're talking algorithm now. This is a simple program to calculate, to just add up two numbers. Harrison, are you with me?
Yeah, yes, sir. Yes, ma'am.
Okay. So this is a simple program to calculate two numbers and return it to whatever is calling it. Is the main function that is calling this function, right? So on this line now, a plus b will take constant time, and the equals to, which is we're trying to store whatever we're getting from a plus b into c, right? We're trying to store it into C. So it will always, no matter how many times you're calling this function, this line 6 will take constant time. It will take the same time. Do you agree?
Sure, yeah.
It's not dependent on anything. It's
Yeah,
just
line 5 at
int
least.
add A plus B, yes, and put it inside C. So it will take the same time. Then return C. Each time is returning C is going to take constant time too, right?
Yes.
It's going to
Yes.
take constant time. So if you want to how do I put it? And what the English is failing me. Oh. If you want to maybe analyze the constant time in big O notation, you make use of the O of one. The O of one signifies constant time taken. Now, in this program, we have just two constant time. That is O of one on line 5 and O of one on line 6. Now, I'm saying the time taking, which is the t here, is equals to O plus 1. That's O of 1, the first one, plus O plus 1, which is the second one. Now, it will evaluate to O of 2, right? O of 2. Now, there's nothing like O of 2 when you're dealing with time distance. So any O of any number, if it's a number, if it's small or large, it will always evaluate to O of 1, which is the constant time. I don't know. Are we together now?
Okay. We're making
Yes,
progress.
we are.
Yeah. Yeah, it will always evaluate to O of 1, constant time. No matter how many O of 1 I have here, it will always be O of 1, constant time. And this is the best case possible. If you can write all your program without making use of any loop or this thing, that each line will just run once, it's not possible though. But this is the best case. You have a very fast this thing, a very fast algorithm, right? Now, going to O of 2 now, um, big O of 2, sorry, big O of n, which is the linear. So let's take, for example, now, okay, let's take an hospital, for example. There's a dentist in a particular hospital. Now, the time it will take for that dentist to attend to one patient, yeah, maybe there's a fixed time that it takes that dentist to attend to one particular patient. Let's say 20 minutes. Now, based on that time it will take, do we agree that we can actually calculate the amount of time it will take maybe in a whole day, depending on the number of patients that the dentist will get? Do we agree?
Mm, yes.
Can you come again with your statement?
Okay, so what I'm saying is, I want to take a dentist, for example, a dentist in an hospital, right? So let's say the fixed time allocated for each patient is 20 minutes.
Okay.
Each time is 20 minutes. Now,
Yeah.
do you agree with me that with this time, we can actually calculate the amount of time that dentist spent working based on the number of patients him or I is going to get?
Yes, yes.
So if it is,
Yes.
so it's going to be 20 minutes times the number of patients, right? It's
Yeah, yeah.
going to be 20 times the number of patients. So we agree that this time, the time it will take for this particular this thing is going to be linear. That's this, the time will increase based on the size, right? As the size increases, the time too will increase. I'm guessing just one response. One response, sorry.
Yeah,
Yes.
yeah, I
So
said yes.
the
Yeah,
time
Yes,
yeah.
yes.
time too will increase. So we can apply the same logic to O of n. And let's use an example, another example for this, right? So I'll write a for loop here. Int I don't need to take the variable. I mean, I'll start with the for keyword and I'll take the variable I equals to, I'll initialize to 0, then I less than n, then I plus plus. Hmm? Or
Yeah.
let's go with the function we've been working with. So let me just define a function that will take in an array. Taking an array. Now we don't know the
Are
number
you
of the array.
combining Python and C?
Hey God, oh, not true. Let me use void for now. Void func. Now we don't know the number of elements that we pass into the array. So I'm going to say n, or let me say the length of the array. Right? Let me remove the n. So the length of the array. So for I, as long as I is less than the length of the array, as long as I is less than the length of the array, what do I want to do? I want to print f I can just printf anything. Let me say you should printf I, right? Printf I. Now, what is happening here? Does anybody want to give it a trial? What's happening here?
You're printing the index of all the numbers in the array.
I'm printing.
Like,
I'm printing the
yeah.
index. Okay, I'm not talking about what is coming out now. I'm talking about we're talking time complexity, right?
Okay, yeah, this is that you are printing each index, so the type complexity will be based on the number of things in the array. So it should be
Thank
O
you
of
so
n.
much.
O of n.
Thank you so much. So at the being the number of elements in the array was five. This array basically the array is running is dependent on the number of size, the number of size or inputs, right? So we can say this array is running O of n because as the number of inputs increases, the number of the time that will be taken will also increase, right?
Yes, yes.
Definitely.
As the number
Yeah.
as the number of this as number of the input or the size increase, like the dentist example, the time taken will also increase a bit. We're
I
dealing
did
with
not get the dentist
Yes.
example.
sorry.
I said I didn't get the dentist example because I was not here when you were giving the example. But this very one now, we definitely increase as the number of elements increase in the for loop.
Okay, let me take the dentist story again. Now I'm saying assuming the time allocated to a dentist is 20 minutes, right? Using that 20 minutes, you agree that we can actually calculate the amount of time it will take for that dentist to we can actually calculate the amount of time it will take for that dentist depending on the number of patients, right? The dentist attend to in a day. Abby?
I didn't get that one now. As in calculate in what sense? Like how do you mean, please?
Okay. The time allocated is 20 minutes. Hmm?
For each
We
patient.
can use it for each patient
Okay.
is 20 minutes. We can use this 20 minutes to calculate the number of hour that dentist is working or worked per day using the number of patients that the dentist attended to.
Definitely, yeah, yeah.
So if it's one patient, it will be 20 times n. If it's two, 20 times, if it's one, 20 times one. If it's two, 20 times two, right?
Yes, yes.
So
Yes.
the same thing applies here. The number of time this our loop will run will be dependent on the size or n. That's the n. It will be dependent on the size. So at it being the number of array is this array have just one element, the loop will run just one time, right? If it's two, the loop will run two times, Abby.
Correct.
Yes.
So so we can evaluate that talking about the big O notation now using the big O notation of n. That's is dependent on the size or the inputs. Are we together?
Yes, we are following.
Yeah.
Okay, so this one, how what's which of the order do we think this will follow? Just print fi.
You like you said, big O of n.
No, each line. Harrison, if you want to calculate the order of notation, you have to go through each line separately.
Okay.
Yes.
So
So
it's going to be as in increasing as in the the execution is going to be based on um how do I put
Well,
it?
I think the second line will be move one because once it goes through it, print it. Once it goes through, it moves to the second one, print one, move to the third one, print one. I think it will be one.
yes, it will be constant. Harrison, it doesn't grow. The printf is not dependent on any growth.
But wait.
Yeah.
You say it to be constant.
Mm-hmm.
Okay.
It will
You go
constant. It will
ahead.
just print. The function is just to print this. So no matter what is come, just print it. Print it. Print it. Do you understand?
I'm getting it now.
Yeah, it's just print it. So this is constant, which is the
Hello,
big
hello,
O.
yeah. I have a question.
Yes, please go ahead.
Okay, please, because the printf, you say it is a constant notation. Okay, but now, the printf will run based on still the size
Wait,
of that
I
array,
know
right?
that's yes.
Huh? Hello,
Sorry,
can you
who
hear
just
me?
spoke now? Yeah, I can hear you.
Edward. Yeah, Edward.
It's been a while. Okay, go ahead, please.
Yeah. Okay. So now you say the printf is under the constant O, right? So now what has
Mm-hmm.
happened? We know that the linear notation is based on, like, independent on another, let me say,
On the
something that's
size.
running on, yeah, depending on
Yeah,
the
on the
size, right?
size.
Okay,
Yep.
now you know that printf, it will run based on the number of times the for loop will run, right? So on that, dependent on size of that array, because it will print the, I don't know if you claim on
The
that.
number of time.
Yeah, the
Okay.
printf will print it out based on the number of times the array will run, right?
Yes.
Yeah, so I think it's still on the size of the array.
No, it's not. It's actually not on the size of the array because see this first line that we evaluated, the for loop. The for loop is dependent on the number that is coming. I don't know if you're with me. It's dependent on the number of size that you're going to be passing into the array, right? The printf
Yeah.
now is just a statement. It's a function, right?
Okay. Yeah. Yeah.
So just print and you're done. Assuming the for loop is not here now, the printf itself is a statement. Yeah, is that a question or somebody's hand is up? Okay. Exactly. Exactly. Thank you so much, Samuel. So are
Yeah,
we together,
Samuel,
please?
thank you. Yeah, I understand. Yeah, thank you. Yeah, Bello, I very appreciate Samuel. Thank you much.
Yeah, you're welcome. So we'll agree now that this one is O of n, O of one, which is constant, and this is O of n, which is linear. Is growing as the size or the input is growing, right? So let's go back to using my superficial function now. So we have the time is O of n, right, plus O of 1. Now, I discovered two tricks in, in calculating this time complexity actually. So the first trick is that the highest order wins. The highest order, like you should always look out for the highest order because the time your program is taking will be dependent on that order. right? Now the second trick is that you should cancel other coefficients. Like when you've gotten the highest order, just cancel every other thing and leave only the highest. I don't know if that makes sense. Does it?
Not at all.
Okay. So look at our um okay, look at my order of hierarchy. I think I'm going to be working with this because I think this is the three that we'll look at for this class. So let me copy it and bring it down here. Right? So looking at this now, this is the best case, right? This O of 1 is the best case. Abi?
Yes.
And in this order, the quadratic time is the worst case, Abi?
Yes. It's the third.
You know,
Option.
the constant time is always the best case. Your program is not dependent on any size. It's constant all through. Now, the quadratic is not constant, it's dependent on something. So in this order now, the constant is the best and the quadratic is the worst, right?
Let me ask you a question, please.
Yes,
Why
please go ahead.
why do you say why do you say it is quadratic? Why not linear?
Uh, because this is
Isn't it simple one?
the linear is O of n, the quadratic is O of n square.
Okay, in
That's
this
n times
case,
n.
okay,
Yes,
it's dependent on the number n times n.
yes, n square.
In this case, how is this n square? I thought this is dependent on the number of item, not the squares, not two and two times the item, just the number of the size of the array. I
We
think
are
it should be
looking at,
linear.
yes, is linear. The one we are looking at presently is linear, which is O of
Okay.
n.
Uh-huh.
I'm just saying I want to make this my trick make sense.
Okay, okay, okay.
You understand? So I'm taking
Yeah.
this order now. The O of n is the best. The O of n square is the worst in this case, right?
Yes, yes.
Abby. So
Yes.
I'm saying
Yes.
this trick is if you want to calculate, we went through each line by line, and we've gotten okay, this one is O of n, this one is O of 1, right? Now we want to calculate the big O notation for this particular algorithm, Abby,
Yes.
right? Now O of n plus O of 1. So I'm saying the trick that I use that makes sense to me, we have different ways of doing things here, is that I take the highest order, that's the highest hierarchy into consideration. Then I cancel every other one. Then I cancel any other coefficient that is there. So does it make sense? The highest order.
Highest
Now,
order
oh,
wins makes sense. But the coefficient is I'm trying to still understand. What do you mean by coefficients?
okay. How do I put it? Okay, let's assume we have a program that want to calculate that is saying, okay, let's say O of 2n, okay, O of 2n, right? That's n plus n, 2n, Abi. So plus, now this 2 here is a coefficient. You don't need it. O of 2n is the same thing as O of n.
Are you writing anything?
Yes, so you
I'm
can't
not
see
saying
it.
that. No.
Maybe it's only
Is
you.
it
I
back?
can see it. Maybe
Okay,
it's
okay.
only.
Okay, can you see it now?
Oh, I can see yours. Okay, I can see it now.
All right. So see the addition I just made here. O of 2n.
Okay, I'm seeing it now.
Yeah, so the 2 here is a coefficient because O of 2n is the same thing as O of n. So you can just cancel this out because if you want to represent it using the big O, you cannot say O of 2n. What you say is O of n.
Okay, okay.
You get? So you cancel the 2 there is a coefficient. You don't need it, it's not necessary. Do you understand?
Yes,
Hello.
perfectly. No.
Hello. Yeah.
Okay.
Please can I ask a question?
Yes, please.
Okay. So now, are you saying that is from this operation here, this t equals to o of n and o of one that give us the two n, the o two n.
Sorry. Sorry, come again.
Like the calculation you were trying to calculate here, the t
Mm-hmm.
equals to o n inside bracket then o one, like that is the linear and the constant. Was that the operation that gave us two n?
No, 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 no. That was not the operation that gave us 2n.
You were just making an example.
Okay,
An
okay,
operation that can give us 2n actually is not a nested loop, but two loops, two different loops.
okay.
Yes, it will give us n plus n, which is 2n, right?
Edward, your hand is up.
Oh, sorry.
So two different loops, like two different individual loop. Like let's take this one for example. This one is giving us O of n. Now, if you have another loop, not a nested loop, oh, another loop beneath it, that will give us O of n too. So that will be O of 2n, right?
Yeah.
So
Yes,
the
yes.
Yes.
two, the two
Okay,
there is not the two there is not significant. It doesn't matter at all. It's still O of
o-
n.
okay. So now, if we have a nested loop, what would that count for?
Okay, we're coming there. But are we together here at this point?
I'm assuming O of n square.
Okay, yeah,
Okay.
we are
Okay, so
together.
are we together? Yes.
Okay,
That's
I
O
the quadratic.
O N
Sorry,
O N.
the ON. So
Okay,
our big O notation for this program is O of n, right?
Let me get this. Let me get this. I thought the
Mm-hmm.
higher should be at the top, or is
It's
it
not.
like coming down?
No, see, the highest, the best case is the one that is constant. O of O. That is why I have this order here.
This constant time, okay,
Yes, this is the best case your algorithm can go through if it's
okay.
constant. I think the ash function that we implemented, it's the program was actually O of n because no matter how many times you're calling that particular function, it will take a constant time. We've done the ash table, right? So that function is very, very good, right? So it's a constant. So that's the best case your algorithm can ever get, the O of one, when we're talking about in terms of big O notation. Now, the worst case, there are other notations. So these are the ones we are looking at for today, right? So the best case in this my own order is this, and the worst case is this, O of n square. Do you get?
Yes, at this point.
Sorry,
yeah.
Harrison, are we together?
As at this point, yes.
Okay.
The only place I'm having an issue now, you said say what are
When
you
I say the
referring to? What do you mean?
highest,
Are you talking about
okay, okay,
the
okay.
best
Let me.
case?
It
You
takes
said
or
you
it
said
takes it takes
best.
priority.
Okay, in this place it is linear now.
No, it is the quadratic now.
No, as in
Huh?
this
No, no, no. We are
regular
not talking about
mathematics,
the.
we're not talking about
We can say it is big O of what
okay.
of n. Are we together?
Okay.
Sorry, are we together?
Sure, sure, I'm here.
Yes.
Okay, if there's any question, please just raise your hand, please. Now, let's take a look at this one, the third one here, which is the O of n square. And to do that, we are going to, let me just copy this function. Let me just duplicate it because we're going to use the nested loop to actually evaluate. Okay, but before we go to a nested loop, let me ask us this question. If this our program was running, is not dependent on any inputs, it's just running just one time, what order do we think this for loop would take? What order
It's,
would it take?
I would say it's going to take the constant time.
It's going to take constant time. Do we agree, please?
Best case scenario.
Do we agree? Do we agree with Harrison, please?
Yes, yes.
Okay. Because it's not dependent on anything, right? So let's move to the quadratic now. So for the quadratic, I'll make an example using the nested loop. So this will run from this to this, and the j will initialize to 0, and it is run as long as it is less than n, then j plus plus. Okay, so let's evaluate this now. Let's evaluate this. Let me bring this into my program. Okay, I want to ask a question. The first loop we worked with, which is the single loop, will it give us, if we are actually printing elements from array, will it give us 1D array or two? Will it give us 1D array or 2D array?
The 2D array.
The single for loop.
No, as in the next for loop we have here, like complete the 2D array. Then if it's single, it's just a simple normal array, single array.
Okay, let me just write a very fast program to solidify that point. So for I equals 0, I, let's say, less than 3, then I plus plus. So I'm not calling any function now. I just want to print out hash with space. I don't want to print out hash, right? With a space. So delete this. Okay, then when you're done, just give me a new line. Let me compile and run this. Okay, so this is 1D array, right? Do we all agree? Please, I'm trying to make a point here. Do we all agree?
I agree.
Any other person?
Oh, yes, I agree.
All right. So let me put the J here and give us the nested loop for J equals to 0. So J will run the same time, 3, then J plus plus. Now print out the same hash. So what is going to happen here?
The 2D array is what we're gonna get.
I'm going to move my new line here because after the inner loop, when the inner loop is done running, I wanted to print a new line before going to the outer loop. So let's see what happens. Okay, so we're getting a 2D array, right? The row and the column,
Yes. Yes.
right? But the row is running 3 times, the column 3 times, right? right?
Okay, three times
Yes, three
and less
times,
than three times. Yeah.
right? 3 times 3. So addibbing our 3 here was actually n. So that will be addibbing our 3 here was n. So that will be n times n, right? Because what we actually printed was a square now.
N
Abby,
square actually.
n square, right? So let's go back to the white and the blackboard. Now let's take a look at this. This outer for loop, we've seen that it will take the big O of n, right?
Yes.
Abby. Now
Yes,
Yes.
yes, yes.
the inner loop too will take
Oh,
the big O of n.
yes.
Now the printf is taking a constant
Constant.
time.
Yes.
That is O of 1.
Of one.
O of 1. Right? So let's go back to the t. T, which is the time taken, equals to O of n. Are you sure I want to use plus here? I don't want to use plus here. That is why I'm making use of the example. So I'm going to use times for this because it's actually a nested loop, right? This loop will run n times. This loop will run n times. Now, this loop is kind of dependent on this outer loop, right?
Sure.
Because if the condition of this outer loop is not true, the inner loop will never run, right?
Sure.
Yeah. So I want to use the times here. So O of n. Then we
Plus.
can also use times here. We can also use times. O of
Why do
what?
we have to use times there?
Okay, no, we don't actually have to use times here. So we're using times here because it's a nested loop. Now this one is just a statement on its own, right?
Exactly.
But this thing is just based on your understanding. I'm telling you, is just based on how you understand and how you can express it. Do you get? Now we are taking a look, we are considering the worst cases, right?
Yes.
Going back
Worst
to the
case.
to the trick, we are considering the worst cases, right? The
Yes.
worst case is going to take
Yes,
priority.
yes, yes.
So we're going to
Worst case.
consider
That's
this and this,
coefficient.
Abby,
Yes.
and the O of 1 will be gone, right? O of 1 is gone. So ON times ON will give us what? What we are looking for,
N square.
which is the
O n
quadratic.
square.
O
Yep.
of n. Are we
O of n
together?
square.
Are we together?
Uh,
Yes. You wrote O of n.
I don't have a way to put that 2 as a square. And if I do it like this, it will be raised to power 2. Do you get? But it's n squared. It's n squared I'm trying to express though.
Okay. Okay. This is better.
Yeah, sorry. Few seconds.
Sorry. The raised to power two is square. The raised to power two is square. If you do raised to power two, n raised to power two is n square.
Raised to power two is not square. There are two different things there.
Okay,
No, the
someone is saying
like
something.
yeah, I was saying that n, like if you put O of, then you now put n raised to power two in brackets. It's the same thing as O of n square. O of n square is n raised to power two. N raised to power two is n square.
Okay, okay, like I said, trust me, simple mathematics like this, it throws me off, right? But we get the point, Abby. We get the point
Yeah.
you were
Yeah. We
trying
get
to
it.
make here, right?
Yeah,
yes, we do.
yeah.
So if you want to calculate the time efficiency or the big O notation, you need to step through each line of your algorithm, right? You need to step through each line. You need to evaluate each line. Then use a formula or tricks that you're comfortable with. I don't know if that makes sense. You just use
Yeah.
a trick that you're
So far,
comfortable
yes.
with to calculate it, right? There are other ones, there are other functions, right? So what's the time? Let's go into the actual topic for today, which is the sorting algorithm. Or is there any question from that one so far? Is there any question? Okay, okay. If there's no question, me, I have question for you guys. So what is sorting algorithm? What do you understand by sorting algorithm?
I would say it's a way of arranging data in a certain pattern, in a certain way.
In a certain way. Thank you so much. Any other contributions, please?
Hello. Yes, I will agree with the other definition, but I just want to add that it could be probably in a descending or ascending order, depending on what you're
Yes,
looking at.
exactly.
If you're looking at
It's,
numbers or integers, ascending disorder. If you're looking at characters, maybe alphabetically, A to Z, Z to A.
mm-hmm. Yeah, that makes sense, and it's very very important actually to take that into consideration. The order at which you want to sort your data, right? The order at which you want to search and you want to sort it. Now there are certain searching techniques, but trust me, when you start when you implement a program that blows up, that everybody that you start getting from 100 users to 1,000 users to 1 million users like that, you need to scale up, right? The kind of data you'll be working with will get, the more your users grow, the larger the data that you're going to work with, the larger it gets, right? And the more kind of tough it will be to undo. So that is why we need to understand these techniques, right? We need to understand the techniques, and we need to be able to go for the best, like the best of the best ones that we know that okay, because you cannot really say this is the one that will be best because how do I put it? Anyways, do we get my point?
Yeah, yeah, making sense.
Okay. So looking at sorting algorithm now, it's there are different techniques actually, and you guys have said it is techniques that we use to sort our data, maybe to make when you're searching or you want to work with a particular data faster, right? Now there are different sorting techniques, right? We'll be taking a look at the bubble sort, the insertion sort, and the selection sort, right? So these are different sorting techniques. It is up to you to determine the one that will be the best for your program. There are many other ones, but this is the first class we're having on sorting techniques. So I think we just take it from the scratch. So everybody will meet up or will catch up with it. Now we are going to be working with the array data structure. You know, the data structure, we have different types, right, that we can use to store data into the computer memory. So we'll be working with an array, and my array name is going to be A. Now I am going to store in different elements into my array, right? So let me just give you random values. Uh, into one. Okay. So these are different techniques. Imagine you're given this. array with this element to sort, right? Now, let's take a look at how we can use the bubble sort first. How does the bubble sort techniques, how does it work? Anybody? Anybody in the house? I think this is one of
Hello?
the simplest.
Okay,
Yes,
let me see if
please.
I can say something.
Okay, can you take it just step by step? So when we're implementing the program, we just follow your step.
Okay, let me see if I can do that. The bubble sort, first of all, we are going to have a starting point, which is going to be the first index in the array.
Okay,
Okay. Then secondly, we are going to also take the second index in the array.
okay, all
Then
right. Go ahead.
we'll compare the first index and the second index. So we check if the first index is less than the second index, but it depends on how you want to do your sorting. But in this case, we are sorting at ascending order.
Ascending. Yes, that is very, very important to take note of. We need to know, I
Yes.
made mention of it. We need to know the order at which you want to sort.
Oh,
So
sorting.
in our case, we are
Yes.
taking the
In
ascending
our
order.
case, we are using ascending order since we are using less than. If we are using greater than, it becomes descending order. Then,
Yes.
if we compare if it is true, then we'll
Check if
swap.
the first index is less than, right? The second index.
Yes, it's less than the second index.
All right. So if true,
We should swap
swap. Exactly.
index.
Do we remember that there's this when we're dealing with pointers, there was this function they say we should write, function as swap. Those people, they know
Yes.
what they're doing. They were getting us prepared for when we're going to be needing these things. Right? So go ahead, please.
So I think that's basically the steps. Then we repeat again.
Okay.
Wow. Wow.
Okay. Okay. Then repeat till
Hello,
sorted,
please. I
right?
don't understand. Please, can you explain?
Yes, we'll take it we're going to
Sorry, can I add that after you swap, then you pick. That means you've compared the first and the second for this stage. Then the second stage, the second iteration, you're going to compare the second and the third. Then the next
okay,
iteration,
yes.
you're going to compare the third and the fourth. So that's how you compare them.
Okay, so basically um we can say compare adjacent index, right?
Exactly.
Abby?
Yes.
Yes. Okay, so let me try to explain this. So we want to look at different ways to actually sort data. In this case, we'll be dealing with integer datas, right? There are different techniques, and each of those techniques have a different method. Each of them have different method which you can use for sorting, right? Now, for the bubble sort techniques, all you have to do is let me bring this let me bring it here. Let's work with this, right? So the first thing you want to do is you compare this and this. That's the first element and the second element, right? If the first element is less than the second element, leave it. But if it is
Swap.
greater than the second element, swap it. You compare when you're done with that one, you compare, okay, let's take for example, we've compared this one now, right? So what will our array look like? So it is the first element is greater, right? Are we
Yes.
together? So the
Yes, it's
first element
greater.
is greater.
We are together.
So we have to swap, right?
Yes,
So we now have 12 and 54,
exactly.
right? Now we have to compare this one and this one. Is it greater than this?
No,
Is
it's still
54
less
greater
than.
than this?
It's
Be
still
less
less
It's
than.
like
still
this.
less than.
So swap.
So our array remains the same, right?
Yes.
Yeah.
Then we compare this
The
and
next one.
this. It still remains the same. Abby?
Okay.
Yes.
Then
Yes.
we compare the 90 and 21. And what happens? They are not the same.
They are
So we
not.
need to swap.
So we have to swap.
So we have to
Swap.
swap.
If we swap, will it's still not in ascending order.
Alison, calm down now. Hey God. But
Yes.
do you understand to
Um.
this point?
Yes, we understand to this point.
Okay, you want to say something, Suleiman?
Yes, I wanted to say something. Okay, it was what Harrison was saying that it was tuned, but I know you are going to come to that most likely because the only thing we do basically was to take the highest number to the end of the array first.
Yes, we bubbled
We
the
bubbled
IS
the
to the
highest
end.
number to the end of the array.
Everything are we
Okay.
together?
That's what happened. Okay.
Yeah.
So
Okay.
we
So
have
now
to
we now
run.
Hello,
start
hello,
This
hello,
one, sorry, this one still have 54 12 instead of 12 and 54.
Sorry.
Since we sorted the first and second element, I think 12 should come first before 54. Our
yes.
newest A.
That's not the end
Okay.
of the
Sorry, that was a mistake. So we should have 12 here and 54 here. Then 12 here and 54 here. Abby?
yes, 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 that's correct. That's a good observation.
54. Yes, somebody's hand is up. Oh, okay, somebody's hand is up.
Yeah, yeah, I'm the one. Okay. Please. The other place you said like before we start sort what I think you're supposed to do first. Like you say, you're supposed to move the last one to the end, or I don't understand that part.
Sorry, come again.
Okay. When you were explaining earlier on that I think is it somewhere or who that said like after the explanation here, you said it was not sorted, but later on you said like we're supposed to move which element first before you start sorting. But I don't understand that part. So yeah,
Okay, so we're dealing with an array, right? We're dealing with an array, Abby.
yeah, yeah,
Now we want to sort this element. So we need to go through each of the element. We need to iterate through each of the elements, right?
yeah,
So we're going to be taking a variable that will be incrementing to move. Do you get?
yeah, yeah.
We're going to take a variable that will be incrementing. I don't know if that answer your question.
Okay, but we don't need to move any element first. We'll continue comparing from the first to reach the end, right?
Yes, this is the first work. The array is not sorted yet.
Yes.
So when it runs through, we need to repeat the step for what we got here. This is like saying this is the first pass or the first run through. Do you
This will
understand?
take this method will take time now to sort.
It's
Exactly,
it's,
but that's what it is now. That's why it's bubble
it's
sort.
taking time because we're trying to break it down step by step. If you put this thing in a system and write the algorithm, it will just give you what you want sharply.
Faster.
Do you
Yeah.
understand?
If the data is small, if the data get large, alpha.
And
Okay,
now,
Harrison.
so we're trying to look at the various way to sort. So it depends on you to choose the one. I actually prefer this method.
Seriously,
Like it's
seriously.
easier to grab and understand. Trust me.
Okay, okay. Let's try. Let's go. Let's go.
Yeah, it's actually easier to grab, right?
Okay.
No, no, no. It's going to be less than. Look at. We are going to be taking. It's going to be less than actually because in this case, 54. When we start at
The
54
go.
is the first
Can
index, right?
sorry for Neymar. Please, I wanted to make this as in say this. Somewhere the goal is for us to as in sort it in ascending order. That is taking all the smallest number first before down to the biggest number. So that's why you see what you
Yep.
have in 19.
Yep.
No,
Yeah.
Yes.
no.
Swap.
Line 3 is
No,
supposed to be
no,
greater than. Line 3 is
that's what
supposed
he's
to be
saying.
greater.
If it
Okay.
is
Okay. Okay. Okay.
smaller,
It's
if you stay there,
supposed to be
now
greater.
I get what he's saying. It's supposed if it's greater. It's supposed to be if it's greater.
Wait now. If the first index is less than the second
That if
index,
12 is less than
yes,
54,
it will be
swap.
greater. It
That's
will
what
be
you're
greater
saying
because
now.
in this case, the first index is actually greater. That's why we swapped, right?
No,
So we
no.
change line 3 to greater.
The algorithm, the step 3 there is where the issue is.
Mhm.
We are supposed to compare first and second. The only time we are swapping is when the second is
Yes.
greater than
Now
the first. When
want
the
to check.
second is less than the no, when the second is less than the first, that's the only time we swap. Because
See,
if the
look
first
at
is
what
less
we're
than the
doing.
second, we are not supposed to swap.
If the first we want to check, right?
Index.
We want to check. We want to swap. So we want it to swap if the first one we are comparing is greater than the second one. Swap it.
Yes.
Yeah, I
Yes.
Understand?
understand. Yeah, yeah.
If the
If the
first
first one is
index
greater
is
than,
greater than
yeah.
the second one, swap it. If not, move ahead.
Yeah, before it was less than. That's what I was complaining
Yeah.
about.
Yes, it corrected. I just make the adjustment now.
Okay.
Right. So to this point now, we've gotten this. So let me move this down here. So we'll go through the step again, which will you guys will agree with me that we'll now need two loops, right? We need nested loop for this because we want to run through this program. We want to run run through this array a certain number of time, and each time we want to check each of the elements inside. Do we agree?
Yes.
We want to run through the array a certain number of time, and each time we want to check through each of the index. So our outer loop is going to be the one that will hold the number of time we want to run through the array. Then the inner loop will be the one making the check, right?
Okay. Okay.
And it will be the one holding the condition. I don't know if it makes sense.
Yeah, it makes sense. It makes sense, at least for me. I don't know for others. It makes sense.
Okay, is it clear, please? Is that clear?
So far, it's clear on my end.
Okay,
Not, like, can you just explain, like, promo light on it? What you can.
okay. Look at this now. If we want to run through this array, right? So what check are we going to be giving? What condition are we going to be giving so the loop will know when to stop when it gets to the end of the array? What condition do we
As in,
think?
are we still going
Okay,
through the same order?
We are not talking about order now. We're talking about the bubble sorts.
okay. The
Bubbles
condition, the first
still on the
condition,
Yes,
right?
ascending order.
yes, still on the ascending order.
Okay.
Okay, okay, okay. Bello, are you there?
Yes, I'm with you.
Okay, so the condition, I think that, like, we'll check if we have reached the end of the array, right?
Yes, what condition do you think we give?
Okay, okay. So now we'll, like, check, like, if zero
No, no,
is
no. I
still
mean,
less than,
inside our loop is our loop that will enable us to go through it, right?
yeah, inside the loop now we declare an index zero, right? To
Yes,
to indicate the first element. Then we'll now we'll now compare it with the length, the size of the array. If it's less than,
exactly. The size, right? But the size minus one, because we're actually going to be starting from zero, right? We're actually
Yes,
going to be
size
starting
minus
from
one is
zero,
correct.
right? We are going to be starting from zero. Now, this loop, I want to explain the reason why I say we're going to need a nested loop. This
Okay,
loop,
okay, yeah, yeah.
this loop is going to run this number of time. Like it's going to run the number of time it will take for our array to get sorted. Now look at what I'm saying. Let me just put down the structure of the loop here. So
Okay, yeah.
this is for the j. J will be less than equals to size 2. Equals to size. Okay, minus 1. Then j plus plus. Right? Now, we have done part 1, Abby. Are we still together? We have done part 1,
Yes, yes, we
but,
are.
but our array is not yet sorted. We need to run through the array again, right?
Yes,
We need to run through what we are getting from this first pass. Okay, maybe we should just
certainly,
continue before
certainly.
I try to explain this. Now let's go ahead. So we've run through the array here. Now we have to do the same thing for this pass too. We'll compare this and this. Is not higher than it, right? So we skip. We'll compare this and this. Is not higher. So we skip it. Right? Now we compare. Okay, let me paste it here. Now we're skipping. So the next thing we're going to do is we'll now check this one and this one too. Right? We're still skipping, Abby. Or are we
Yes.
swapping?
Yes, yes.
We're still skipping. Now I'm pasting it here again. So this now and this one, and we're still skipping, right? Why is it that is this thing that is pasting for me? Delete.
I know what you said.
I don't understand though. Okay, so now we are comparing 81 and 21. So we need to swap here now, Abby.
Yes,
So we're going to swap here. So 21 is going to come here, and 83 is going to be here. Abby, can you see that we're making progress? Harrison.
yeah, we are making progress. I know it's going to work. I'm only saying it's going
But
to
it's
take
taking
more
time. But do we
time.
understand? Can we try to
Yeah,
implement? I'm trying to explain why we are going to need the nested loop. Do we understand the steps now? Can we implement it?
yeah, sure, sure.
Is everybody agreeing to that?
Yes, we can.
Is there any confusion, please, in the house? There's no
Okay.
confusion, right?
Looking at this now, I think if we'd be using
Yeah,
a nested loop, because we don't know when it will be completely sorted, we don't know. But what we do know is
exactly.
that we can run the loop like how many the array size is 0, 1, 2, 3, 4. By the time we run this 8 times, it would have no, is it? Yeah, like 8 times, like nested
No, no, no. We only need to
looping.
run it
In
4 times
actually.
actually.
Yeah, four
Actually,
times
it's
for the
5, not
outer
4.
loop, then another
The
4
size-
for the inner loop,
the-
Exactly.
no, no.
making 8.
It's
One,
no,
two,
no. 4 times for the
one, two.
outer loop.
Uh-huh.
The inner loop. Oh, that's true.
It's 4 times. Look at this now. This will run 4 times. Then it will give us what we want because it will
That's
No,
push.
like
it's actually
Ah,
four
yes,
times.
yeah, it's 4,
yes, it's four
but
It's
times.
in the
actually
real
Yes.
sense, it's
4 times.
almost like it is 8. The outer loop is 4, but the inner loop, it's running twice. For the first
No,
This
see,
iteration,
one is four. This one is 4 times.
like,
This one is 4 times.
again,
If you run through again, it will be 4 times. So to do this bubble sort, your condition should be the size minus one because it's going to be starting from 0.
0, yeah, yeah.
We have five. We have five
No,
elements here now.
but I think
Samuel has a point. This loop, yeah, I don't think it's running 4 times. So since it's going to be running like the outer loop says, let's assume like what we're working here now. The outer loop says 5 minus 1, that's 4, starting from 0, right? Now, if it gets to the inner loop, it's going to have to run 1, 2, 3, 4. then go back to the outer loop. Then come
Mm-hmm.
again, run one, two, three, 1, 2, 3, 4.
Yes,
Go back again.
that's what we want.
Hello,
Is that
hello.
that's more than 4 now?
It's actually
That's
going to
that's what
run
we
like
want now.
it's actually
I
going to
think that's
run like
five.
16 times, oh,
It's five now.
in
Wait
my
now,
opinion.
it's four. See, the inner loop will run four times. The outer loop will run four times. The inner
Okay.
loop will run in this case. Our size is five, right? One,
Mm-hmm.
two,
Yes.
three, four,
Yes.
five, right? So j less than okay, I less than five minus one. So
4.
I less than four, right?
Okay.
So this will run four times. J less
Mm-hmm.
than four too. This will run four times.
This will run more than 4 times. This will run
No,
um,
it will run
four
four. The
times
outer loop.
times 4 times.
No, the outer loop will run
The
four
inner
times. The
loop will
inner
run
loop will
four
run
times
four
times
times.
4 times.
Okay,
No,
see, but see. Okay, let me just try saying this. The inner loop will still run
mm,
4 times. Then the outer loop will run 4 times. But
see,
the one that
I see.
determines the
It,
length
it,
is
it will not be
the
four
first
times
loop.
four. Oh. It will not be four times four. Oh.
It will not be
See,
4 times 4.
how do
You
you
wait.
remember how the
Okay.
the how nested loop work? When if the condition
Yes.
is true, it goes into the inner loop. Then the inner loop will run as long as the condition is true. Then it goes
Hello.
back.
Hello.
Hello? Sorry. Um,
Hello.
can I say something,
Yeah.
please?
Hello.
Yeah. Yeah. Go on.
Oh, network. Hello.
Okay. Um,
Hello. Yeah, we
Can
can
Harrison,
hear
you?
you.
it's
We
your
can
Hello.
hear you.
network.
We can
Okay.
hear you. Go ahead.
You know,
okay. What I'm saying is, Val, this is how this is going to work. For the first, I don't know, I'm not seeing your screen very well. But for the first scenario, we're going to start
Sorry.
from we are going to start from 0 to n minus 1. That's going to be 0 to 4. That's for the outer loop. Is that correct?
Sorry. Can you
as
take that
long as
again?
that will be 0 to 4. I agree.
0 to 4. That's what the outer loop is going to be like. So for the outer loop, for every zero in the outer loop, when you go inside the inner loop is going to run 4 times. Then it goes back for one. If it goes inside the inner loop again, it's going to run another 4 times. Then it
Another
goes
four.
back.
That is 2 times now. Inside
That
the
is
inner
two
loop.
times. Yes. Then if it goes back again for 2,
That's four
it
times
goes
four.
inside
You
the
guys be
inner loop.
counting it.
It's
No,
going to
Exactly.
run
now.
another 4.
God Almighty, Harrison. Let's take a simple example for this thing. See,
I
let's just take.
understand, but it's
Wait
running
now. Wait.
inside.
The inner loop cannot run four times four. Let's take I is equals to zero. Eh?
No, we are saying
Then
the
I less than
individual
two.
checks are actually 16. Like the checks, the individual elements is going to check like
Exactly.
16
If you
in
check,
total.
if you check, if you
Not that
check
it's
very
running
well now,
16
Val,
times, but 16 times is going to check the
Yeah.
individual elements.
No,
That's the
no. If only
16 we are talking about.
it's run 3 times.
if you check very well, you notice the time complexity for this algorithm is going to become n square.
Yes, n
See,
square. That's true.
let's be clear
Exactly.
with ourselves here. Harrison,
Man.
Network. Get with, get size, and everything. Get with, get size, and everything.
Mm-hmm.
Okay.
so it goes into the inner loop, right?
Uh,
Yeah,
yes,
And
it goes into the inner loop.
it will remain inside the inner loop until the condition is false.
exactly.
It will
So
keep on
let's check the
executing
first.
until the condition is for on the
Yeah,
yeah the condition is
yes,
false.
until the condition is false. Now,
Yeah.
the condition is
She's
true
not
the
yet
first
went
time,
out.
right?
You said
The condition is true. Zero is less than two.
Yeah, so it will go in.
0 is
It will
less
print
than
ash.
2. Okay.
Yes,
It will
it will
print
print
ash
ash.
Yeah,
one
yeah, it will print ash. Now J plus plus one is less than two.
It will still go in and print ash.
and print ash again.
Yes. Now J will now be three. J will now be two. Is two less than two? No.
No,
No.
it will
So
break out and go back to the outer
it
loop.
will come back to the outer loop. Outer loop will be one. So can you see
Now it
that
has
this
done
inner
it
loop
has
is
done
running?
that action twice.
The inner loop is running
Yes,
just two times.
exactly. But that's the same thing we've been saying.
It's running just two times, not four times. Do you understand?
Okay, maybe we are not using the right word. What we are saying is this. What I mean to say is this. Like this very one you explained now. We asked it to run two times inside the inner loop for every count of the outer loop.
Outer loop.
Yes, now.
Yeah. Yes.
That's what we are saying. So if it has run two times inside the inner loop for one, if it goes back to the outer loop and run
It will
again
run
increase
for
again, it will come back and still run again that amount of times. So it's more like it's going more than as in that's the count I'm referring to as more than as in not just two. It's coming again to come and execute that same thing again, that number of times that's expected inside the inner loop.
But the inner loop
I don't
will
know if you get
run.
what I'm saying.
which
But
means
the
the
inner
inner loop
loop
must have gone 4 times.
That's what I'm saying.
and the outer loop too is running how many times?
As given by as we specified.
Okay. You know what?
Hello.
Let's
Hello.
write
Do you
this.
get?
Let's write this program. Let's write this
Hello.
program and work with
Oh,
it. Because time is going.
okay,
Yeah.
okay, okay.
Oh, someone say something.
Um.
Someone wants to say something.
Yeah. Yeah. It's me. But don't worry. Just go on. Just go on.
No, go ahead now. Go ahead, please.
Okay. Okay. No problem. Okay. So now the thing with this double loop, this nested loop, is that
Naturally.
there is something that they call the length and the width, right? The outer loop determine the length, while the inner loop determine the width. For example, now even the example you just gave now, the one under, just scroll down.
Okay.
You see that first loop here, it determine how many times the inner loop will run. That means that is the length. For example, now if we come down here to print a new line, just after we print the hash and we print a new line, just after the inner for loop, you see that it will print the hash two times first. Then when it's go down, you know that it now enter the outer loop. That specify how many times the inner loop will run. Do you understand? So if the outer loop is run, it's just determining the length, how many times that inner loop will run. That means if you're having I less than two, it will print the for loop, the inner loop, it will print that hash two times first. It will go into a new line. Just assuming you have a new line there. That means the length now, right? That means the length where we are not through with the length, right? It will go there, increase again, then go back and execute the number of time inside that the inner loop, right? So the thing there is that the outer loop is just specifying the length, while the inner loop specify the width. So I don't think that clears everything.
Okay. Okay, it
Yeah.
makes sense. Are we together now?
Sure, sure.
Are we together? Okay, but we understand the reason
Yes.
why we're having nested loop, right?
Yeah, yeah.
Yes.
All right. So let's try to implement the program using this our blackboard. So I'll just create a file here called Bubble. Sort the T. Can we see both screens? Can we see both of my screens?
I can see your screens.
All right. So the normal way is to always write the function different, but we're going to be implementing it this thing at least for this one inside the main function, right? But we can always separate it later on, right? So the first step is let me create my array. Um, so so 83, 90, 21. Right? And I like getting the size immediately. So my int is going to be the size of my array divided by the size of the data type I'm working with. This will give me the size. Hope I've not lost anybody.
Yeah, yeah, we
Are
are
we
good.
together?
We are still here.
All right. So int I and j. We're working with two loops, right? So our first loop, we said we're going to start from zero, right? From index zero. Then it's going to be I less than size minus one, right? Then I plus plus. Then we'll have an inner loop for j equals zero, j less than size minus one, two, then j plus plus. Okay, so this is where we start implementing the code. So we want to give the check, right? We want to give the check that if AI, that's the first index, is greater than AI plus one, Abi. Are we still together?
Yeah,
Yeah, we
altogether.
are here.
So if AI, right, is
Okay.
greater than A
AI plus one.
AI plus one, which will give us the next index,
Yes.
right? So if it is greater, what do we want to do? We want to swap,
Swap. Greater.
right?
Yes.
In ascending order. Okay, we want to swap.
No, it's not. Is it AI? Abi AJ? We are working with the inner loop. Nobody corrected me there.
You didn't see that. I didn't even see what you did.
Is my screen frozen?
No, as
No, we're
in, I
seeing
wasn't
you.
really paying attention to what you're typing.
Okay.
Okay, so we want to swap. So how do we swap? We
If
need a
it's if
temporary.
We need
AJ is
another variable.
greater, so
Yeah,
you
we need
take
a
a new
temporary
variable.
variable. So
Yeah.
we will not lose what the first index is, right?
Properties.
So temp equals to AJ. Now we can now swap AJ equals to AJ plus
Plus
one,
one.
right? Then
Okay.
our AJ plus one now will now be equals to what? To our temp.
Temp.
Temporary.
And
Swapping.
that is it. This will swap it right now. Abby,
Yeah.
Yeah,
Yeah.
yeah.
want to swap it. So I think that is it. That's why I tell you that I prefer this bubble sort. To implement it is not even that difficult to grab.
So after that, let's try printing the array so that we can like see
Now
how
see
how
what
it's
is
sorted.
printed.
Yeah,
Okay, so how do we print the array? We need another loop now.
yeah,
Yeah, we need
another loop.
a method loop.
Yeah, let's print
We need
it
another
before
loop.
sorting. You can say something like before sorting, you print it out, then after sorting, you print it out again.
Okay, yeah, yeah.
Okay, okay. I less than I plus plus. So this one will be after sorting, right? This will be after
Yes.
sorting. So printf percent d. I want to leave a space between them. Then a of I. Then we need a new line. So before we are printing here, we want to print f
Yeah, this thing is the messing up.
after sorting, new line. So let me just
Your
put it.
screen.
It's
I know.
lagging. Yes,
Yeah,
We
yeah.
but it's okay.
we
It's
we
okay
don't
now.
we don't have to add a variable swap to see if we swap or not before completing the for loop.
Sorry.
A variable swap. If we swap, we turn it to true, and if not, we can break the for.
The loop. Yeah, yeah. I get what you're trying to say, but this is that is
Can
the how
I
do I put it? That is the
I don't get what you're saying,
what do
no.
you
I
say?
would have
That's
liked
like
us
that's
to
like the optimized form of bubble sort.
Optimize. Thank you so
When you're
much. That's the
optimizing it,
English. That's
because
the
because
English.
basically
So
what we
that is
have now,
optimizing. See,
what we have now
yeah.
can do bubble sort, but there is a condition of where how about there was no need to even swap after all when everything was already sorted. With what we have, it will still run the loops instead. So we can use that one to check if maybe there was a swap and we need to continue checking. But if there is no swap on the first run, it simply means the whole array is already sorted. So there was no need to even run the rest of the loop.
Yes. Yes. Thank you so much.
No, like 21 is only checking for index of the first and
See,
the second. That's
what
two
is happening
adjacent
is
index.
look at something. Look at something. What is happening is, when we run this first pass, we know that okay, the last index is the highest, right? We've pushed the last index to the end, Abby.
Yes.
So we don't actually need to run through everything again. Our this thing should decrement. We don't need to run through everything again. Now, after sorting this one, now look at this. We know that the last two are
Yes.
sorted, right? So instead of running through the loop 4 times, instead of stepping through all the loops, we'll give limits that okay, we don't need to check the ones that are already sorted. I don't know if it makes sense. Now, eventually, we'll get a sorted array. But since we say that our array should run this number of times, it will complete the run even after sorting. So what she's trying to say is we just give a check that if there's no swap, just break. That means the array is sorted. Does it make sense?
Yeah, it makes sense, but just continue from like let's finish it and see the output from this one.
Okay, so we have the before sorting, then the after sorting. So let's see. We can actually put a variable that if there was a swap, we just increase it. They will not print that variable. We'll declare a variable, we initialize to 0, right? So inside our this thing, this is what is checking the swap. So we can check that if we can now after this line, we initialize that our swap to our variable to 1. Do you get?
Yeah.
So we'll be incrementing it. Yes. Then after everything, we now print.
Wow.
Mm-hmm.
Wow. 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 That's nice.
So let's see the output of this one. Oh, okay. So I pushed my this thing down. Okay. So before sorting, we have this, and after sorting, we have this. So our bubble sort is working. Can we see it?
Yes.
So our bubble sort is working.
Yeah,
We want to
cool.
clap for ourselves.
Yeah.
Okay, so let's
So
try to
yeah, implement that stuff,
What
right?
copy order for you?
implement that this thing now. What Aja is saying. So what changes do we think we'll make? Where are we making the changes?
At
Inside
line
where we are having
24.
we are checking for the
At line
condition.
24, we have to first declare a variable that
Exactly.
is, yes, that's an is
Then we call
initialized
it
to
swap now.
zero.
We
Okay.
can call it swap. We'll give it
Okay.
0. So
Then
line
come to line
20, is it line
24.
24? Are
Uh,
you sure it's line 24? What do we want to do on line 24?
we want to check. We want to increment swap
Okay, so um
24,
swap.
not 28.
Why not?
Wait,
This line
wait, wait.
24,
Okay, okay, yeah. Okay, yeah, yeah, 28, 28.
yeah. So swap equals to should it be plus equals to
Swap
1 or just swap
increased,
equals to 1?
increased by one, plus one,
No, no,
plus
no,
those
no.
kinds of stuff.
I don't think it should increase. We're not trying to check out the number of times yet. Too. We're just trying to
No,
see. if a swap happened.
That's what I'm trying to
We
say.
cannot increase.
My idea is swap will be increased by one. Then you check if swap not equals zero, break.
Mm, okay, that makes sense, Harrison, but that's more like adding more codes to codes. But I think
So
the way swap to do what?
Okay, look, see,
variable that will be implemented.
so see, to solve that
If
two variable,
if
see,
variable
Samuel, to solve that two variable, see what we need to do. Okay, we initialize swap to zero, right? Now, if there was a swap after running through all this loop, if there was a swap, swap should be one.
Yes.
Now, outside this for loop, we can give a condition that if swap is equals zero, that's if there was no swap, eh? That means after running through the inner loop that is actually checking and swapping, if there was no swap, just break.
Mm.
Does it make sense?
easy, but this is
Yeah, that makes
quite
sense.
an easier one, self.
So the plus plus now we just like we're trying to increment swap. We don't need to increment it more than once. So
Actually, it
if
actually it's still we can still increment and still do something similar, like what I
well,
just said. Like I said,
let's give
can
let's give it
increment
a
it at
try.
like 28.
So swap plus
When
plus,
28,
right?
if you increment it, then say if in 31, if swap not equals zero,
Okay.
break.
Yes, it will work. Ah, it will work. Oh, Agbakoda, Harrison. I think this
But
should
where is
work.
it? Where is it?
It
But
should.
does this mean that we are going to initialize our swap inside the if loop? The first if loop.
Yes, we you know that is the first if loop that is actually checking and swapping.
Yes.
Is the first if loop that is checking and swapping. So we want to check if a swap happened. So we need to implement it inside our if. You get? We need to implement it inside our if. So do we think this will work?
This is going to work, but it's more like swap. The swap is now more like a counter as well to count the number
Yes, the
of
swap
times
is more
swap
like the
actually
counter.
happens.
So we
Mm.
can use the swap as the counter. Wait, let's even see the
Yeah.
output. Let's
What
see the
I'm
output.
saying is that
We
there's
should
no
we should
swap equals to
initialize
zero.
after the for first for.
And you are checking if swap is not equal to zero.
Oh, our code
We
don't
should
scatter. Oh.
we
You know
should
the
we
swap
should
thing.
initialize the swap after the first for loop.
Okay, our swap should be initialized here.
Yeah, but after each iteration of e, we should reinitialize it to zero.
Okay, should be equals to zero, right?
Yeah.
All right. Okay, let's see. Is it this is what you meant, right? On line 20.
I can't see your screen
20.
anymore.
Yeah.
Can anybody else see my screen?
Yeah,
Yes, we
yeah, I can see
see
your
it,
screen.
but I
You can
think
see your screen.
it's frozen.
No, after running through, our swap will always be zero, right? So if this continues is true, where
Yeah.
what Aja is saying is that after running through and swapping, we want to put our swap back to zero. Yes, after this inner loop finish running, we want to initialize it back to zero. So it's the same thing if we put swap equals to zero is equals to one here. I think if we put the swap equals to one here, we don't need to be changing it back to zero because it will always be one as long as it has entered. Right? But let's see 22. 32. It's Harrison that gave this condition. No?
My idea, I said my idea is from what we have in line 25 and to line 28 is actually the logic for swapping,
Yep.
right? And then line 23 is actually as in the condition on which the swap is to happen. Now, if it checks that condition, say it takes the first index and the second index and it checks, and it is not, and it is false. What we have in 23 to 25 to this thing 30 will be skipped. Do you get? But if it is true, meaning that the swap will take place, and if that swapping take place, the this thing 29 line 29 will be increased, meaning that there is a swap. Now, if there is a swap, if there is a swap, do you want to continue the loop?
Sorry, I want to pick a call, but you guys can go on.
What
Just
we're trying to do is actually make sure that if there's no swap, it should break, right? Okay, if I think Samford, I think you're right. It should be equal to equal. It should be equal. You are correct.
Yes, equal to zero. The swap.
Yeah. If swap equal.
No, no. I think equal equal.
So it's sorting. Let's give it some other variable that does not as in let's arrange it. Let's give it a normal ascending order value. So it's working. We can actually put some kind of notification saying there's no change, something like that. Bubble sorts. Yeah, I don't think it will work at the first instance. Let's find out. But how do we find out if it actually break at the first instance? Like this now, we don't know if it actually break at the first instance. We need
wait.
some kind of alert.
We can we can print
Yes, so it printed
I and
like
G.
like in line 34. Line 34 before the break. And we need some kind of way to measure as in how many in the index.
Print I.
Print out swap. Swap is
I.
increased.
You know, if you want to print swap there, it will still be zero.
The swap will be actually the index because
to
look
I.
at swap is set at 0. So it's actually we go in as in line with the index. Okay, line 20 will set it back to 0 at every iteration. So that will be comment that line 20 now. Are you sure?
Sorry about that. Okay, what are we trying to do now? Okay, so that is why I think I actually tried that on my own. And what I did was, the way I implemented my own was my swap was equals to 0. My swap was equals to 0. So I took another variable called pass, another variable called pass, right? Now, after each swap here, I incremented pass plus plus. So after each swap plus plus, right? Then I now printed out swap. I said swap. I now printed out pass and the new line, then pass. Right? I think this was how I checked. So let's see. Let's see what happens. Wait, am I seeing the code?
Look at what happened in the code before you run that thing. Oh.
Mass check if you go work first though. What happened?
Look at what we had in line 20, swap is set to 0. In line 6, swap is set to 0. Okay, not line 6, line 8, swap is set to 0. And then in line in line 33, so we are checking if swap equals 0. Look at, does it go in line with what you have in mind?
Swap is one. Sorry, it should be one on line 21, 29. It should be one on line 29. Let me see if it works first. Okay, so J and temp. What is it complaining about? Am I seeing the call?
Yes, see here, yes.
I don't know what it's complaining about. I declared my variable with declaration of I with no linkage. I with int.
I think you copied the declaration at the end.
Okay. Okay. Okay, so it's giving us 12, which is way above what we are doing. It's giving us 12. So after swapping,
Have you run the code?
yes, so
I didn't even see what you did here.
it gave us 12.
So how did you fix that error? How did you
I
fix the error?
redeclared I redeclared the variable down. All those variables I redeclared them. So I just deleted the ones that are down. Okay, so it's giving 3 now. Can we see?
Why? Why? Did you do something different now?
Yes, we are trying to see the number of time it will take to swap instead of going through all the arrays. You get?
Okay,
We're
okay,
giving it
okay, okay.
we're giving it a check that will make it not go through all the arrays. Abby?
Okay.
So we gave a check. So now I just after this loop is the one that is controlling the swapping, right? Line 21 to 31 is the one that is controlling the swapping. Abby? So if you run through, my path should increment. Anytime it goes through, my path should increment. Then at the end of everything, I'm just printing out pass here.
So pass is the number of time it's actually iterated before it break.
Yes. Instead of going through the number of time we say the loop should run. So we gave a check to stop when it's fully sorted. Right. So
Wow,
this
this
this is
is
the
nice. This is
optimized
nice.
this is optimized bubble sort.
You need to
Samuel, do you
remove.
understand? We need to remove what?
How about the swap? The swap at line 20. There is a swap equal to 0 at line 20, and there is a swap at line 8.
Line 8. Yeah, I don't think it matters though, but we can just remove this zero. We can just remove it here and
It
just
does matter though. It does matters
How about the one at 20? We are supposed to be using
because
just
it's
one.
always setting zero. It's always setting swap to zero.
okay. Let me try and run this again and see.
If we don't set it to zero, there will be an issue based on the logic we have.
It's sorting it. It's sorting it fine.
Fine. So that
Try
means
it again.
the only swap we need was the one at 22. Inside the loop, swap is 0. That's why it's running. It's not needed. Or better still, remove the one inside the loop and leave the one at the top. Let's see if it will run.
Okay,
If you do the one, if
I
you
think
move the one inside the loop, we have an issue. Remove the one at the
Yes,
top.
remove it. Yes, remove it. Let's see. Let's see what happens.
I've removed it. Which
No,
one
the
should I
one
remove?
inside
I've
the
removed the
loop.
one at the top. Okay, so I should leave the one at the top, or I should remove
Yes.
that one too.
See, let's do the one that will give us problem first. Move the one at the middle, line 20.
Leave the
Then leave the
one
one at the
inside.
top. We
Remove the
have
one
an
inside the loop. Exactly. Remove that one and leave that one at the top.
Okay,
we have an
initialize at
issue
the
like
top,
this.
right?
Yes. Let's see what
I suspect
happens.
we have an issue like this. Let's find out.
Okay, well let's move to the second the insertion. Then we'll call it a day. Oh. It's working. It's working
But
perfectly.
this
It's
time it
working.
is 4. But this
But
time
now
it
it
is
is 4, no more 3. So something's happening.
Okay, it's true.
yes. So that means it's the swap inside the loop that matters.
Sorry.
That means it's the swap inside the loop that matters. That's the one we need.
Yes, the
Yes, now
swap inside the
I
loop
think
is
that
very
was why
paramount.
I just say we should put it there. Right. So let me just put it back. Okay. So is there any question so far, please? We all understand this thing, right? We are trying to look for different ways to sort arrays. Right? Is there any question? Okay.
No
So
question
if there's
from
no
me.
question, all right. So let's look at the second sorting techniques, which is the insertion. After this, we'll call it a day. Right. So Suleiman, do you want to help us with the step for insertion?
No, maybe it's no other persons.
All right. Who wants to help us with it, please? So let's try to analyze how it will work before even implementing the code. So the
How does the
insertion.
insertion sort work?
So what happened for insertion is that you actually insertion sorts. So you divide your array into two. You divide your array into two parts. One is the sorted part. The other one is the unsorted part. So let me bring back my array. Yeah, this is let's work with the same array, right? So you can take any of these elements as your sorted parts, or to make the matter more easier, let me just put this here like this. I'm splitting this array into two, right? This side, like from this side, this 54, is my sorted. I'm assuming that will be my sorted part, right? Now, the one from this part is my unsorted array,
Mm-hmm.
right? So why am I assuming that this one is a sorted array? I'm saying that because this one has just one element, right?
Yes,
This sorted part is having just one element, which is 54. Now, an array of one element is sorted now, Abi,
definitely.
right? It's sorted. Now, how this one works is that we'll start iterating from the second index actually. We'll start running our loop from the second index. And what we'll be doing is that we're going to have, first of all, we're going to have a temp variable, a temporary variable that will hold this
54.
this no, the 12 that we're going to check.
Okay.
Yes, we're going to have a temporary variable that is going to hold a of I. We will initialize, in this case, we initialize our I to 1 because the 0 is our sorted part, right? Now, we're going to start from 12, which is the unsorted. I don't know if we're together.
But it's still supposed to be A of I or A of I plus 1.
That's why I say we initialize our loop to 1. You know, the last one we
Okay,
worked
we'll
with,
start
we
from 1.
initialized
We'll start
our
from
I.
1 to 0.
Yes, we
To 0.
initialize
Yes,
our
I understand.
yes to 0.
I
So in
understand.
this case now we're going to initialize our I to 1. So A of I, A at index I, right?
Yes.
Which will be 12. This is 0, this is 1. So I'm going to store my one variable into the temp. The reason why I'm going to be storing my variable into the temp is because I want to overwrite this index, right? Now, after storing it into the temp, I'm going to check for the
Who is
right
there?
space. I'm going to check for the right index, for the right space on the unsorted part, on the sorted part, sorry. Does it make sense, please? Aja, are you saying something? You're sounding very low. Are we still together? Hello, am I still in the call?
Yes, we are with
You
you.
are here. You are here.
Okay, is it making sense?
Yes, sure.
Does it make sense? So what is happening is for this part here, we're going to, for this technique, we're going to divide our array into two. The sorted part, right? And the unsorted part. Now, I'm going to take my first index, the element of my first index as my sorted array, and every other one as the unsorted. And I made mention that the reason why I can assume that the 54 is sorted is because this part of my array contains just one element, right? It contains just one element. Now, an array of one element, there's nothing like sorting now, right? It's sorted already, Abby.
Yes.
Okay, so it's sorted already, right? So the next thing I want to do is I want to have a variable that will hold this, the next element in that array, or the first element of the unsorted part. This is the sorted part. This is the unsorted, right? So the next thing I want to do is, sorry,
Go on.
okay. So the next thing I want to do is I want to have a variable that will hold this, my, the first index of my unsorted array, because
Mm.
I actually want to override what is here. Yeah, I want to move what is
Mm.
here to the sorted part. Now I can't just move what is here to the sorted part. I have to check if it is at the right index. I have to compare. If it is at the right index,
Okay,
I don't know.
I
Does it
understand.
make sense?
Yes, it's making sense.
Are we together? Can we try to implement it? 'Cause that whiteboarding will take a lot of time. Do we understand? Yeah. Yes. We need to check. We cannot just move this one from here to here. You can imagine just moving this one from here to here. That means our 54 will come before 12, which will not make sense because we say this part is the sorted part, right? So if we're moving this element from here, we need to check for the right index here. We need to check
Mm,
if what is here is greater than this.
mm.
So we need to check
Okay,
if what is here is greater than this. So if what is here is greater than this, we want to move this one. We want to move this one index ahead. Then we insert this one at that index that we just moved.
okay, okay.
Yep.
Yes, that's why we have a
Yes.
temporary.
That's why
That's why we have a
I
temporary
have a
variable
variable here that is holding whatever I'm losing.
that
I'm
is
going to
holding
lose
12.
this. I know.
So
Do you
you can
get?
lose the memory for 12 and still have it in temporary. So you use it later.
Do you get? I know that I'm going to lose something if I shift it. Do you understand? That's why I have a temporary that will hold it for me.
Mm. Yes, let's implement.
Harrison, are you still here?
I don't understand which one they talk. Oh.
Okay,
Okay,
let me
so
try and see if I can explain to the understanding.
all right.
Okay,
Yeah.
what happened is we have an array and we need to split this array into two. You are assuming you are not literally splitting it like splitting it. You in your mind you're splitting it into two. So the first array, that's a of 0 now, you assume that one is sorted already because it has one element. And of course, as long as the element is just one, it's sorted. Then the other part, which is unsorted, where you have your 12, 83, 90, and 21, you assume they are unsorted. So now the first element in your unsorted element, which is 12, you're going to create a temporary memory where you are going to keep 12. So you now have a place where you have 12. Then you now check if 12 is less than or equal to 54 or probably more than 54, depending on what your condition is. You now notice if 12 is less than 54, so what are you going to do? You're going to carry 12 and replace it to where 54 is and carry 54 and replace it to where 12 is. Is that not? Hello?
Yeah, you are correct.
Yeah.
You are correct. Go ahead.
Yes.
Should I whiteboard it before we implement?
It's making sense. It's making sense now.
Okay, okay, go ahead. Sorry, go ahead, please.
Yes. So that's what you now do. So you remember you have a temporary memory that is holding 12. So by the time you make use of, by the time you carry 54 and replace at the index of 12, then you now replace your temporary memory at the index of 54. So those two are now sorted. So your next sorted is now going to be 12 and 54. Then unsorted now becomes 83, 90, and 21. Then you repeat the same process.
Mm.
I
Repeating
don't
the
know.
same process now. We're not comparing. We're not comparing 83 with 54. That is index 2 with index 1. Is that what we're doing?
Exactly. Exactly. You are now comparing 83 and 54.
I have okay. That means index 0 and 1 is sorted. So we have to
It's
watch for
sorted.
1 and 2.
Exactly.
Okay. Okay. Okay.
So should we go ahead with the implementation?
Let's do it. Let's do this.
All right.
Okay. Okay.
Maybe
Let me see if
during the
I can. Let me see
implementation,
if I can. No, no. Let me
sometimes
see.
during whiteboarding, you really don't get it sometimes. But when you are implementing, because you can actually test it and see what happens, maybe you might
Okay, Harrison,
position.
can you try to explain in your own words? Let's see.
Okay,
Harrison,
okay.
yeah.
From I'm here. I'm getting you. So, Sam, from what I get here now is to we start with this instruction sort. We start on assumption. We try to as in, and it actually does work. We assume that the very first index, what is there, just that one. We divide our array into two, and the very first index is sorted. Now, at array index 0, once we divide, we have to create another variable that is going to hold the value that array index 0 is holding. So it's like more
No,
like the new variable is going to hold a
array
copy of
index
Array index one.
array index
array
0.
index one is
One.
Okay, array
no.
index 1. Sorry, array index 1. I mean to
Yes.
say. So the new variable is going to be holding the copy of array index 1. Now, we then compare if array index 0 is greater than array index 1. If the value at array index 0 is greater than array index 1, you then swap the value, putting the value at array index 1 into array index array index 0. Then the new variable that you created, you then put that the value inside that new variable into array index 1. So that way now you swapped it. Do you get?
Yep.
Then you move to the next index.
Yes.
Not all other elements,
Array
just
index
for the
zero.
first elements.
Yes.
For the first element, then you after you have done that,
Array index zero will be our
for the yes, I guess index 1. Then if if it's greater than, if you swap it, but if it's not, you leave it. I believe you leave it like that, then move your this thing to the next in the end to the next index. And I believe that's how you're going to do it till you get to the very last. I think this is let's step deep again. If you saw you saw the first and
No, it will
second, then
be not
move
because
to
by
the
the time
next
you repeat it,
index. You repeat the same process till you get to the end of the index.
Let's implement the code. You'll see. Let's implement the code. Yeah, Samuel. Let's try and implement the code. So we'll see. Yeah. So we are going to be working with two loops too here,
Yeah, next step deep again.
right? We're going to be working with nested loop. So for now, our I is not going to start from zero. Our I is going to start from one. Our sorry, I didn't even declare the array. Okay. Let's take the same value, but we can just mix it up though. Okay. So we're going to be starting with one, and the reason why we're going to be starting with one, our I with one, is because this is the one we want to first deal with. We are going to assume that this 79 is the sorted part, right? So we want to start from this part, right? So for I is equals to one, and okay, let me take my sides. Size of int. So as long as I is less than size, then increase I. So I less than size. Then now inside this my first loop, hmm, I'm going to initialize. Okay, I need a temporary variable that will hold what we want to override, right? Now, inside this my first for loop, before I start implementing, I want to store the value that I want to override inside temp. And the value I want to override is a of I. A of I is what? This is a of 0. This is a of I, my I, right? So this is a of 0.
Yes.
This is a of 1, right? So a of I is this. I'm working with this 66 now in this case, right? Now I want to initialize this part too, right? So I'm going to assume that this part will be my J. My J should be handling this part. My this thing, okay, my J should be handling this part. It will make sense. So I'm going to say my J equals to I minus 1. Does this make sense? If my I was 1, I want my J to be this one that I'm going to compare with later, right? If my I is this, I want my J to be this. If my I is this, I want my J to be this. If my I is this one, I want my J to be less than this. Does it make sense?
So J will always be one less than I.
Yes.
Yeah.
It's always going to be one less than I.
Okay, as a way of tracking it. Okay, that's nice.
Yes. So I'm going to take a loop, another loop. I can work with a for loop here, but I think a while loop will make the condition very clearer. A for loop can work too, but I'm going to take a while loop, right? So my inner loop now is going to be as long as J is greater than or equals to 0. Remember that our J is the one handling this part, right? Our J is the one handling the sorted part, right?
Mm-hmm.
Yes, yes,
Now
yes.
we don't want our J to be anything below 0, because anything below 0 is at index minus 1 now. It doesn't make sense actually.
In Python, it does.
Yeah, but in this case though, what we don't have any element at index minus 1.
I know.
Right? We don't have any index. So as long as our J is greater than or equal to 0, and let me see. Okay, AJ, we want to compare this to what we have in our temp now. So as long as our AJ is greater than temp, does this condition make sense? What is our J? Our J is 0, right? In the first case
Yeah.
here, our J is 0,
J
right?
is 0.
It is okay. It's greater or equal to 0, and then
Wait, what is
index
our J
this.
here? Our I is 1, right? And we
J,
say J
J
should be
is
I
0. I
minus
is
1.
1.
So
J
our
is
J is 0,
0 as
right?
at this point.
Okay,
Yes,
so A at index 0 is what? 79, right?
Yeah,
79
79.
Okay, so if it's greater
greater
than
than
temp,
temp.
what is inside our temp? 66, right?
Temp is 66. So we have
So
to
66.
swap.
77 is greater than this, right?
Yes, so
Then
we
J
swap.
minus minus. We see why J minus minus very soon,
Why is
right?
J
So
minus minus? I don't understand.
okay, J is minus minus because we have just one element here now. But imagine we've sorted up to this point here. Yeah. Now we've sorted up to this point. Like from 12 here is our sorted array. From 31 we've not sorted,
Hmm.
right? Now imagine we're using our temp is 31. Hmm? We want to check if 31 is greater than this. Our J will start from 12, right?
Okay,
So once it begins J,
I
so
now
it will check
understand.
for this much.
I now understand why we are minusing J. But here's the thing. I don't think we should be doing this J minus minus as at this point because it's kind of confusing.
Okay, it's while loop. It's a while loop. Sorry. I forgot I'm not working with the for loop here. It's a while
Okay.
loop. Thank you so much. It's a while loop. So do we understand this condition?
I get it clearly.
Okay, Samuel, are we still together? All right.
Never clear.
So if it is greater, if anything at our eye, for example, now 79 is greater than 66, right?
Okay.
So we want to move 79 to one index ahead, A of J. Like, we want to shift, we can override this now, right? Because we've already stored it inside temp. This 66
Temp.
is already inside temp, right? Abby?
Yes.
Okay, so we want to move this 79 to this index now. So A of J, which was 79 now, we want to move it plus 1, right? Yes, someone is
Yeah. Yes.
raising their hand. Okay,
Mhm.
Aja, go ahead. Aja, you want to say something?
No, 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 no. Go ahead.
Okay. So are we,
Hello? Yeah, it's me.
oh,
Hello?
okay, go ahead, please.
Y-
Yeah.
Yeah, please, why are we comparing J minus or equals to zero? Yeah, yeah, please.
Because we want our J to be a valid index before we're able to check whatever we want to check or make any move we want to make.
Oh, okay. But anytime we are going, like we want to check, right? We already know that the J will be a valid index now. Like I is always one, so we know that it will always be a valid index. So is there a need to check?
Let me see. Let me see. Okay, you know what? We're checking. We'll run the code if it works. Then we'll remove it and see what happens.
Okay, no problem.
Yeah. So, but do you understand the condition though? Do you understand the condition?
Yeah, I understand. Yeah.
Okay, so we'll now decrement J. What we're trying to do inside this while loop is we're trying to look for the perfect index for our unsorted elements. We can't just move from this place to this place. We need to check for the perfect place that will be good for that index, right? So when it's done with the loop and it has gotten the perfect place, what do we want to do? We want to insert that our temp inside that perfect place, that perfect index for our element. And that is it. And that is it.
How would this have been done using for loop?
Okay, if it was a for loop, let me implement the for loop here. So for we already initialize our J, right? So
Yes.
we can just put this semicolon, Abi. Now we'll now give the condition greater than or equals to 0, right? And what is our next condition? A of J is greater than what? Temp, right?
Mm.
Then J minus minus. I think this should work for the for loop. Abi, this should work for the for loop
Yeah, so I feel the for loop is much easier now. I
to
don't know.
understand.
Yes.
It depends, but to me, I think that while loop is kind of straightforward. The condition there is kind of straightforward.
Okay. Well, I kind of feel comfortable with the for loop.
Yes, even me, I'm used to the for loop. But you can see in this case here, we're ignoring this part, this colon. We're ignoring this part. We're focusing on just the check in the while loop here. It's a lot to take in actually. The checks are kind of complicated, right? So the while loop is making us just focus on what we are checking for without the extras.
Mm. No, but of course, we still have to do the decrement somewhere in the
Yeah,
while loop.
but it's
Definitely.
the same thing though. It's the same thing basically.
It's the same thing basically because we still have to do the decrement somewhere in the while
See,
loop. Else, it
yeah,
will
I'm
become into.
decrementing here.
Hmm.
I'm decrementing on line 19.
Hmm.
So which one do you think we should go for?
Let's just use the while loop. The while loop is okay.
All right.
The
So
while.
are we together?
Yes, we are.
Before we even do this thing, let me see if it works. So sorry. Oh, I'm not printing it yet. So let me just print it here. Okay. Okay. Print f before sorting. There's another class, so we're taking much time. So for I equals 0, I less than the size, I plus plus. So print f a of I, a of I. Then give me the new line. Ah, give me a new line. Okay, so let me print the. Okay, this one is after. Oh. 1, 2, 1, 2, 3, 4, 5, 6, 7. All right, so this one is the before. So let's see what happens. Today 11 12. Okay, so it's working. It's sorting it. Right, but do we understand the implementation though?
Um, Please, can you just explain more on the implementation again?
Okay, so this is what is happening. Let me go back to the code. I think we started from line 18. Started from line 18. So, for example, let's take this our array here. Yes, let's make use of this our array. I'll be explaining the code with the array. Now, when given an array and you want to make use of the insertion, sorry, and you want to make use of the insertion, you want to use the insertion sort techniques to sort the array. You divide your array into two parts, right? You divide it into two parts. The first index is going to be the first element at the first index is going to be the sorted part, because this part of the array will contain just one element. And of course, one element array is a sorted array, right? Now, this other parts, like the other element from index 1 down to the end of the array, is going to be the unsorted part, right? So you can understand why we started our loop from I equals to 1, because we want to start working with this 12, which is at index 1. Do you get? That's why we initialize our I to equals to 1. And our loop should run as long as our loop should run to the end of the array, right? Now, to this, you see this 12 here, which is at index 1. We want to shift it to the other side of the array, right? Now, you agree with me that if we just say, okay, swap this and this, the 12 might end up being after 54, and 54 is greater than 12, which will not make sense since we say this part is our sorted array. Abi? So if we want to move this 12, we need to actually look for the right place or the right index for this 54. Yeah. So the condition we are giving here, okay, we said the temp, this temp now, we're storing a of I. That's a of 1. In this case, our a of 1 is 12, right? So our temp is holding 12, right? Our temp variable here is holding 12. Now we're initializing our j, which is the variable of our inner loop, to I minus 1. This, our 12 is the I, which is 1. Our j is equals to I minus 1, which will be 54, right? Are we together? It will be
Yeah,
54
yeah,
now.
yeah.
So our temp
Yes.
is holding 12. Our temp is holding 12. Our j I is going to be any index before this thing, which is index 0, which is 0. So our temp is 12, our j is 0, right? Now, we're coming into this loop. What this loop is doing is shifting. If our temp, if our condition that I want to check is greater than this, now look at how it works. So now we're giving a condition that as long as j is greater than or equals to 0, our j is 0, our j is equals to 0. This condition is true. Both conditions must be true. The and, right? Now this one is true. Now let's evaluate this one. A of j. Our j is what? Our j is 0. Thank you.
Zero.
So what is a of j here? It's 54, right?
Yeah, 54.
A of 0 is 54. So 54 greater than, what is our temp? Our temp
At
was
12.
12, right?
Yes,
So
12.
if it's 54 greater than 12,
Yes, true.
yes, yes, 54 is greater than 12. Now our a of j plus 1, that's 0 plus 1, right?
Yes,
So
that
0
is
plus 1, which
12.
which will be 1. No, not 12. Oh.
Like,
We are working with array or pointers. We are moving to the next index. So we're not actually adding to the value,
yes,
right?
yes, I know.
It's an
Like
array.
the
So
next
we're moving
index is
to,
12, right?
no, like our a of j was at was index a of 0, right?
Yes,
Okay, you're right, so we're moving to the index where 12 is
yeah,
sitting, right? So
yes,
we want to
yes,
put a of 0. What is that a of 0, which is 54? We want to put it
yes.
at where that 12 is. You can see that we'll lose 12, right? One, right?
Yeah, yeah.
So we're now decrementing minus minus. Our j was 0, Abby. So
So
0
yeah, our
minus
J
1. Yeah, so it will be minus 1 now, right? Our j
but
will
I
now be
think
minus 1. Yes,
are
go
you
ahead.
seeing that place? Are you seeing that place where you say A, then inside that bracket you say J plus one? I think that
Yeah,
will
it's
make
not
the
it's
J.
not it's not
Yeah.
it's not inside the loop. It's not inside we need to the loop needs to finish running before it goes out now, Abby.
Yes, yes,
This
exactly.
is
But um,
increased by one in the
hello,
while loop.
Yeah, the while loop needs
hello,
to finish running. So we need to evaluate this j minus minus, Abby.
hello.
Yes, I can hear you.
Okay, so what I'm asking is that are you seeing that place where you say A, then in index J plus one inside the while loop there? I think if you add one to J, the J now
Mhm.
will be one now because J initially is zero, right? The
Yes,
J
so
will
it
be
should be
one.
a of
Yeah,
index 1, right?
yeah, exactly. So if we are doing J minus minus, that means the J now will be zero, no longer one, right?
No, no. This line is not affecting what j is. Oh, this is talking about the index.
Okay,
And this
okay,
is
okay,
talking
okay.
about the value itself.
Okay, that means J is zero. So if we say
Yes.
J minus minus, it will not
J
be
will
a
be,
negative, right?
yeah, minus one actually, Abby.
Yeah,
It will be minus one. And our loop needs to run again, but this condition is now false now.
yeah, it's
Abby?
false, false.
This condition,
Yeah,
so the while
false.
loop, it will not go into the while loop again, right?
Yes, exactly. That is false. The J will
So
be false. But
yes, yes, the J will be false. Now, when the condition will not go into the while loop again, it will come to this line 28, right? Now, it will shift. Okay, we already shifted. So A plus J plus 1 is shifting by 1, right? It's shifting what was at 1 or what was at 0 to 1. In this case, it's shifting 54 to index 1 and it's going to put temp at that index. Does it make sense?
yeah, yeah, it makes sense. But the only thing there is that I don't know why we are decrementing J there, because
Okay, so
after that,
let's remove it and see what happens. This is you're talking about. We should just check for if it's greater, right?
yeah, with that, then with why are we decrementing the J, the J minus
Okay,
minus?
we're decrementing J because, okay, imagine in this case now, imagine our sorted is no longer just one element, is now two. Abi? Is now
Yeah,
two. Now, assuming it was five that was here, let me assume so it will make sense that it was five that was here. We want to, the five will first check for 12, right?
yeah,
It will first, is the five is looking for the right index to settle down in, Abi?
yeah, yeah.
To first check for 12. Now, there's another thing here. What if that one too is greater than or is less than 5? We need to check for this one too. That's why we need to decrement our J to check here. J minus minus to check here. If there's another one, it to check. If there's another one, it to check again. Do you understand?
I don't understand that, but it's cool. We can just continue. I'll like go for further reading.
All right. So let me see if removing that condition it will work. You're right. It's actually working. Without it, it's working. Yeah,
Yeah, that's cool.
it's actually
Yeah.
working. Is there any question? Because there's another class by I think 8:30 or so. So we need to go and rest before that one.
So I wanted to ask this size. How do we arrive at the size? I joined late,
Okay,
please.
so this size here, if I do size of A is what? One, two, three. Okay, to make it more explanatory, let me just remove this first, right? Then I'll just print size here. Send the new line. Now print out size. Right. So let's see what it gives us. So recompile and run it. So can you see what it's giving us? It's giving us 28, right? And
Okay.
our program is misbehaving. It's giving us 28 because come to think of it, this is we're dealing with integers and one integer allocates how many bytes? 4 bytes, right?
Yes.
One integer will reserve 4 bytes. Now we have 1, 2, 3, 4, 5, 6, 7. So 7 times 4 is what? 28, right?
It's yeah.
So if we don't divide by 4 by each element, it's not going to give us the right size. So we can either say size of, let's say size of A of I will give us 79, right? And
Mm.
79 is one integer. So but me, I prefer to just do it divide by size of int, which is 4. So 28 divided by 4 now will give us the 7. If we do size of A itself, it will be the number of element times 4, which is 28. We don't want our loop to run 28 times now. We just want it to iterate over the number of elements we have here.
Yeah, in the list.
You get? So that's why we need to
Okay.
divide it by the number of the data type we are working with.
It's a bit
So that's
complicated than Python. Just have been easier to get the length of the list.
okay with the len, right? We can actually use I think we can use string len now.
Okay.
Yeah, I think we
Ma,
should do. Yeah.
ma, um, since we are we are removing one from J. I mean, in line 23, we are removing one from I, and
Yeah.
in line 27, we are adding one to J. Why not just initialize our I to 0, and there will not be any need of subtracting one from it? How about that?
Okay, so you mean we should start running our loop from 0, right?
Yes, if we
Let's do
start
it.
our loop
Let's do
from
it.
0, then our J,
Okay.
we now see J is equal to I. We uh Will it not work?
J equals to I. So we want to start the J2 from 0.
Yes,
Okay. So it will come into the condition A of 0 greater than temp. Now, our temp and our J and our A of J will be the same thing. J is equals to I, which will be 0, right? Our I,
yes.
we started I from 0. So our J will be equals to 0. And our temp, A of I,
Okay, we can now make that term I plus 1.
okay, I plus 1. Okay, so what would this do? A of I in this case is 50, okay, 79, right? Plus 1, which will be 66. Okay, so our temp is A of index 1, right?
Yes,
Then our J is 0.
yeah.
So let's run it and see. Okay, I think something is wrong here.
Eh,
Did I put 0 in my list? It's removing the
no.
8 from that 0. It's removing the 8 from the 0. Can you see? Like the 80.
Okay,
And
it's
but without
removing.
that, I think it's actually sorting, but it's starting with 0. And it should be 80 after 79.
And because of the length of the list, so it cuts off 80, I think.
0 part of 80 here.
Uh,
See the 0 part of 80 here. Yeah, let me see what we.
Yes.
Your screen is frozen.
We have another class in 30 minutes. Though.
Naima, you still there?
I think I think maybe a network or so.
Okay.
But I think we've done a lot of justice. We have a Python class by 7:30.
Yeah, yeah, yeah. About 30 minutes to go. So I think it would be best we end the session here. Let me stop the recording.
Yeah. All right. Thank you.